Hi, um, this is geometry video. Geometry. I Please forgive me for my spellings. I do make mistakes with my spellings. Geometry. I hope I got the spelling right for the geometry. This is geometry review one. I'll be discussing lines and polygons, and also I'll be discussing triangles. So it should be a short 20-minute video. So when you have two parallel lines and a transversal line passing through it, then these angles formed out here, A, B, C, D, E, F, G, H. So the names are there, the A and D, they are equal, they are vertically opposite angles. D and E, they are interior alternate angles. Yeah. So you have A, D, E, H. Hang on. You have A, D, E, H, which are all equal. So there are one set of angles which are all equal, A, D, E, H. And similarly, you have B, C, F, and G. Second set of angles which are all equal. And then you have corresponding angles. So A and E, as you can see over here, they are corresponding angles. And they're equal. So don't remember the names, vertically opposite, adjacent, and all those things. Just understand the relationship that you see in front of you when two parallel lines are drawn and a transverse line passes through it. So A, D, E, H, these are equal, one set of angles. B, C, F, G, another set of angles. Okay. Now, obviously, if you take any one from group one and any one from group two, and if you add them up, you'll see that they add up to 180 degrees. So A and C are adjacent angles, they add up to 180 degrees. A and C. A and B also are adjacent angles, they add up to 180 degrees, and so on and so forth. Okay, now, um, here. So this is a diagram drawn out here, okay? And if I were to say this is A, this is B, this is C, and let's say this is D out here. So if I tell you A is 110 degrees, yeah. B is, let's say, 100 degrees, okay. Then would you be able to tell me the value of C plus D? Okay, we don't know whether these lines are parallel or not. So would you be able to tell me C plus D, what is C plus D equal to? You might not be able to tell me because we know that A and B is 210 and the interior angles of a quadrilateral is 360. So we know that 150 is a measurement of this angle out here and this angle out here together. Okay, so we can say that 150 is a measurement of the angles out here and here. Okay, and C and D, they are, you could say, supplementary angles. What do you mean by supplementary angles? So if you have a straight line like this, then the angle is 180 degrees. And suppose I say this is 130 degrees. And if I were to ask you what is the supplement of 130, then you'll say it is 50 degrees. And hence 50 and 130 become supplementary angles. Similarly, we have complementary angles. So this is a right angle. Yeah. And if I have in a right angle, if I have this to be, let's say, 40 degrees, then what is the complement of 40? Then it is 50 degrees out here. So that's the meaning of complementary angles. 40 and 50 are complementary, 50 and 130 are supplementary. So you could say that C is a supplement of this angle out here. D is a supplement of this angle out here. But we can't tell you exactly what C and D is, but can we say what is C plus D equal to? Can we say what is C plus D equal to? Is there a possibility? I know that these two angles together is 150. Yeah. If they're together is 150. So let's just say that this was X and this was Y. And I know X plus Y is 150. So I can say that C plus Y is 180. I can say X plus D is 180. If I add them all up, then what do I get? I get C plus D plus X plus Y is equal to 360 degrees. And what do I know about X plus Y is 150. So what is C plus D equal to? 360 minus 150, correct? And which comes to 210, right? It comes to 210. So yes, we can find out the value for C plus D. It is 210. So seemingly a difficult question, but if you apply logic, you can solve it. Got it? So what is C plus D? C plus D is 210 degrees. That's my answer. Interesting. Okay, moving on to the next screen. Right. We'll discuss polygons because that question on the previous screen was actually a polygon question, a quadrilateral question. So anything made up of enclosed within three or more than three lines is a polygon. This polygon is a triangle. Then there's a word called regular polygon. Yeah. It simply means all sides and all angles are equal. A regular polygon is a polygon where all sides and all angles are equal. So if this triangle, if I were to say a regular triangle, it simply means an equilateral triangle. Okay, it simply means equilateral triangle, right? So within triangles, we have scalene triangle. So all sides are not equal. Isosceles triangle, two sides are equal, like this. And then we have the equilateral triangle. So my focus is on the polygons right now. I'm not getting into the triangles. Yeah. So in polygons, just 2, 3 points I want to discuss quickly. That if I were to extend this line out here, yeah, and then if I were to extend this line out here like this, and if I were to extend this line out here like this, then the sum of the exterior angles of any polygon is equal to 360 degrees always. It just doesn't mean for a triangle, any polygon, quadrilateral, square, trapezium, anything, uh, a pentagon, a hexagon, octagon, nanogon, and so on and so forth. The exterior angles add up to 360. Now you might be confused that, okay, never mind, I'll use a different color now. So even this is an exterior angle. Even this is an exterior angle. So the concept of exterior is that it is the, basically, if this is my interior angle within the polygon, then the outside one is the exterior angle. So when you say sum of the exterior angles, do you mean both this E and E together? Should I consider them? No. You only take one exterior on each vertex. This is called a vertex. This is called a vertex. So only one exterior on each vertex. One exterior on each vertex. And that way, if this was X and Y and Z, then X plus Y plus Z would be equal to 360 degrees. Got it? Let's take a hexagon, a regular polygon, a regular hexagon, where all sides and all angles are equal. Yeah. Then if this is my exterior angle, so I'll use a different color now. So if this is my exterior angle, this is another exterior, exterior, exterior. So I'll only take one on each vertex. So if I were to name them A, B, C, D, E, and F, then A plus B plus C plus D plus E plus F will be equal to 360 degrees. Remember that. So that was one point. Now the next point on polygons. First of all, understand regular polygons, equal sides and equal angles. Okay. If the word regular is not there, then do not assume anything. Okay. So the next point is that the sum of the interior angles, sum of the interior angles of any n-sided polygon is equal to n minus 2 into 180 degrees. Sum of the interior angle. So if you were to consider a quadrilateral, for example, yeah, okay, n-sided. So quadrilateral has 4 sides, so n is 4. So use this formula, 4 minus 2 into 180 degrees. So we all know that quadrilateral interior angles, the sum is 360. But we got this as 360. Use pentagon. Pentagon has 5 sides, so n is 5. So we know 5 minus 2 into 180 is 540 degrees. Got it? So sum of the interior angles, these all will be adding up to 540 degrees. Understood? And the last point is that for any n-sided polygon, the number of diagonals is equal to n minus 3 into n by 2. So if you consider a three-sided polygon, three-sided polygon is a triangle. Triangle has how many diagonals? N is equal to 3. 0. It has no diagonals. And it works. 3 minus 3 is 0. But if you take a quadrilateral, when n is equal to 4, n is equal to 4, then you have 4 minus 3 into 4 by 2, which is 2 diagonals. So we know these are the 2 diagonals, 1 and 2. And similarly, you can find out for a pentagon. Pentagon, it is 5 sides, 5 minus 3 into 5 by 2. So that's 5. And we can see that these are the 5 diagonals. So I'm going to use a straight line. 1, 2, 3, 4, 5. It forms a lovely pentagonal star or pentagram. Anyway, so those are the points on polygons. Okay, right. Now we'll move on to triangles. So in triangles, interesting properties. First of all, the Pythagoras theorem. Applicable to right triangles. So for a right triangle, these are called the legs. And this is called the hypotenuse. Okay. So according to the Pythagoras theorem, the hypotenuse square, so let's just call them A, B, and C. So hypotenuse is AC. AB and AC are the legs. So the square of the hypotenuse is equal to the sum of the squares of the legs of the other two sides. And hypotenuse is the longest side, basic. Yeah. So that's first pointer. The next pointer is that you'll see that, they'll play around with this theorem in various ways. Yeah. So for example, let's consider a Pythagorean triplet. All right. So first I'm considering 3, 4, 5 right triangle. So this is a very common Pythagorean triplet which they can use, and you can probably remember this Pythagorean triplet so that in case if you get something like, let's say 20, something like, let's say 12, yeah, 12 should be here, or maybe 16 out here. Let me say 16. Okay. Yeah. Okay. So if the 16 is not there, you can either use the Pythagoras and find out the answer for the unknown side, A, let's call it A, or you can simply say, okay, this is kind of 5 times 4. This is kind of, you know, 3 times 4. Yeah. So then this would be 4 times 4. And so basically, they are nothing but a Pythagorean triplet based on 3x, 4x, 5x, where x is 4. So that way you save time. If you know one is 20, okay, 5 times 4, one is 12, 3 times 4, then the other third side will be 4 times 4, 16. You don't have to solve it using the Pythagoras theorem. So if this was 20 square, and then this is 12 square, and this was a square, then you can simply solve for a square. Got it? So instead of solving, you can remember it using this triplet. The other triplet is the 60 degrees, 30 degrees, 30, 60, 90 triangle. So that's a triplet. The opposite 30 degrees is always x, opposite 90 degrees is always 2x, and opposite 60 degrees is always x times root 3. Remember this. Yeah. And the third triplet is the isosceles right triangle, where these two sides are equal, and therefore x and x, and this is x times root 2. Basically half of a square. And if you remember, the diagonal of the square is root 2 times the side. So this is root 2 times x. And again, they can ask you questions instead of wasting time. Yeah. So let me give you a few examples. So let's say this is drawn like this. So we know that it's isosceles and it is a right triangle. And if I tell you this is 5, and then I ask you what is A and B equal to, simply say A is 5 and B is 5 times root 2. Got it? Yeah. Again, so I give you 5 out here and tell you what is A and B. So you can simply say it is 5 divided by root 2, and that is also equal to B. Similarly, if I were to give you a 30, 60, 90 triangle, yeah, so I don't need to write 30. It's understood that the third one is 30. Yeah. So then if I were to tell you this is 12 and ask you what is A and B equal to, so you know that opposite 90 is 12, opposite 30 is half of that. So this B looks like 6, but it's actually 6. Yeah. And therefore A, which is opposite 60, is root 3 times 6, or 6 times root 3. Understood? And so there are infinite triplets. But the commonly asked ones are these three, which I discussed: 30, 60, 90, 45, 45, 90, which is the isosceles right triangle, and the 3, 4, 5. Yeah. Okay. So one last one. So let's say this is 30 degrees out here. And if this is, let's say out here, I give you 5, for example, out here, opposite 60 is 5, then all you got to do is, okay, opposite 60 is x times root 3, and that is equal to 5. So what is x? X is 5 by root 3. So this opposite 30 is my x, and this is 2x. So therefore, my value for x is 5 times root 3, and this 2x would be 10 by root 3, therefore. And that's how we can quickly solve rather than using Pythagoras theorem. So obviously, unfortunately, over here, given only 5, you couldn't have used the Pythagoras theorem. You could have used trigonometry, obviously, but trigonometry is a different ball game, which they don't really ask in part 8 questions. Yeah. So now some more properties of triangles, right? So before I move on to the other properties, this is one thing of which I wanted to discuss earlier about the Pythagoras theorem. So we know that in a right angle triangle, the hypotenuse square, let's call it C, and let's call this A and B. So we know C square is equal to A square plus B square. Okay. But what if they are playing around? Yeah. They're playing around. So let's just say that they're playing around in the sense that they're saying that A square plus B square is lesser than C square. What does that indicate? If A square plus B square is lesser than C square, does it indicate an acute angle? So for those who do not know, acute angle is less than 90 degrees. Or does it indicate an obtuse angle? An obtuse angle is greater than 90 degrees. So which of this is A square plus B square less than C square? All right. So we know that if A square plus B square is equal to C square, then it is a 90-degree angle. So what happens if the A square plus B square part is not equal to C square? It's lesser than C square. So does that mean it is an acute angle formed, or does that mean an obtuse angle is formed? Yeah. So like that, they'll play around. So all you got to do is just consider a simple triplet 3, 4, 5. Yeah. And then play with it. Yeah. So this is 90 degrees. And suppose if it was lesser than this diagram out here, yeah, meaning it was lesser than 5 square, okay, and not equal to 5 square, then your diagram would probably look something like this. It would try, and I'll just draw it on top of it so that you can understand. So you probably say, okay, till here it is 4 from here, and for 3 square plus 4 square to be less than 5 square, okay, for 3 square plus 4 square to be lesser than 5 square, right? For that to happen, meaning if this was, let's say, a not 4, okay, and let's say if it was lesser than 4, only then it would be lesser than 5 square, right? So it'd be incorrect of me saying 3 square plus 4 square is lesser than 5 square. So let's say 3 square plus some number out here square is lesser than 5 square. Now that number cannot be 4. It has to be lesser than 4. And if it is lesser than 4 and my 5 is constant and 3 is constant, yeah, then clearly this value will have to be something smaller than 4. Got it? And in that case, it forms an acute angle, right? So you got to figure out a square plus b square less than c square. And to figure out whether it is obtuse, so then you can say that, okay, if it's going to be obtuse, then a square plus b square will have to be greater than, c square, right? So then all you have to do is take another 3, 4, 5. I'll use a different color. Yeah. And then imagine that uh, 3 square and 4 square is greater. So if it is greater, then in that case, if I consider this to be 3 square and 4 square, and it has to be greater than c square, then this cannot be 5 anymore. It has to be something other than 5, right? It has to be lesser than 5. Are you getting the picture? So in that case, what will happen is you'll have 3 out here, 4 out here. Yeah. You'll have 3 and 4. And let me see. 3, 4. Yeah. And I could very well have a 4 out here, which forms an isosceles triangle. I can yet have an acute angle that way. Making sense? 16 plus 9, I can yet have an acute angle. So you'll have to figure out. But what my point is that they're going to play around. They're going to play around and ask you questions based on, is this forming an acute angle? Is this forming an obtuse angle? So you got to figure it out. Okay? Yeah. Okay. Anyway, moving on to the property of triangles. So one of the important properties of triangle is that if I've given you 3 sides A, B, C, then you take any one side, A, B, or C. That one side has to be greater than the difference of the other two sides. So I'm putting a mod out here. Mod means I want to take a positive difference. Okay. Yeah. And it has to be lesser than the sum of the other two sides. So that's an important property of a triangle. Any one side you take, whether you take A, B, or C, yeah, if I'm taking A, then A has to be lesser than the sum of the other two sides, and A has to be greater than the difference of the other two sides. Okay. So, what kind of question can be based on this? Yeah. So consider this parallelogram. Okay. Yeah. It's a parallelogram. And if I were to give you dimensions of 6 centimeters and 8 centimeters, then if I were to ask you, what is the range? What is the range? Or which of the following is the range of the diagonal? Of the diagonal. Yeah. You can apply this theory which I discussed about the triangle. So we know that this is my diagonal out here. Yeah. And we know that if this is 8, this is also 8. And if this is 6, this is also 6. Because that's a property of a parallelogram. So I know my diagonal, yeah, has to be lesser than the sum of the other two because it's a triangle property, right? This is my triangle, right? So this diagonal has to be lesser than 14, and at the same time, the diagonal will have to be greater than the difference of the other two sides. Therefore, it should be greater than 2. And hence, this is my answer. The range of the diagonal is between 2 and 14. Will it be less than equal to? No. All right. It can't be less than this is because this does not state out here a greater than equal to b minus c, a lesser than equal to b plus c. It simply states a has to be less than b plus c, a has to be greater than the difference of the other two. And hence this cannot be 2 lesser than equal to 2 is less than the diagonal and d is less than 14. So that's another important property, and they can again quiz you on these properties of triangles. Okay, but in geometry. So triangle property used in a quadrilateral question. Next property. Um, so this was one. The other one was Pythagoras theorem property about the triplets and all. And yeah, I guess I mean that's it about the triangle properties. We can move on to important formulas of triangle properties. For example, the equilateral triangle. So if you are given an equilateral triangle, so the important formula out here is that the area is root 3 by 4 times side square, and the height, or it's also called the altitude, is root 3 by 2 times the side. Okay, remember that. Then there's Heron's formula and other things. So um, for those who don't know, they'll never ask you such things. It's just good to know. Heron's formula, it's the formula for area, which is square root of s minus a, s minus b, s minus c, and this is applicable to any triangle, where s is the semi-perimeter. For those who don't know, perimeter means the sum of the sides. Okay, semi-perimeter, and ABC are the sides. ABC are the sides. Okay. I don't see the time. Hang on a minute. So I couldn't figure out how much time, how long this video has been. So just one more last property, similarity. Very important property. Okay. Very important property. So if I give you two triangles, right triangles, let's just say ABC. I've got another right triangle, PQR. Can I say the two right triangles are similar? No. But if I say that this is 30 and 60 and this is 30 and 60, yeah, now they are similar. Now they are similar. Can I say they are identical? No. Because identical means congruent, and congruent means the sides, angles, everything is equal. Sides, angles, all equal. So they are not identical, they are similar. But for similarity to happen, the angles have to be equal. For similarity to take place, the angles have to be equal. If the angles are not equal and they are simply just two right triangles, for example, let's call it DEF. So this is 40 degrees, this is 50 degrees. So is ABC and DEF similar? Is ABC and DEF similar? No. Understood. But ABC and PQR are similar because the angles are the same, right? Now, if DEF, and I've given you another triangle, let's say RST, and let's say this is X, Y, and M, and this is also X, Y, and M centimeters. So, congruent means sides and angles are equal. Therefore, triangle DEF is identical, or you can say congruent. So there's a symbol for congruency. Yeah, I don't remember that. So I'm just going to say DF, triangle DF is congruent to triangle RS and T. Understood? All right. So now the properties of similarity, that's just two main properties of similarity. So suppose you've got PQR with angles A, B, C, and you got RST with angles A, B, and C. So when two triangles are similar, so I know the similar part is somewhat like this. Yeah. So when two triangles are similar, PQR is similar to RST. So the property is that when two triangles are similar, their corresponding sides, PQ to RS, will be equal to the other corresponding sides, QR to ST, will be equal to PR to RT. Meaning, I would like to rephrase my sentence. I made a mistake. The corresponding sides will have the same ratio. So earlier I might have said the corresponding sides are equal. No, the corresponding sides have the same ratio. So PQ upon RS, that's a ratio which will be equal to the other corresponding sides QR upon ST, which will be equal to the other corresponding sides ratio PR and RT, like that. For example, if you were to consider this question out here, yeah. So when I say these two lines are parallel, then I know that these two angles will be equal. I know these two angles also will be equal. So obviously the third angle, which is C, is common to both the triangles. So let's call them P, Q, R, S, and T. So therefore I can clearly say that PST and PQR are similar triangles, right? And if I were to say that, like this, if I were to say like this, it simply means that PS is equal to SQ, right? And then if I were to ask you, what is the ratio PST triangle is similar to PQR triangle? So I can say PS to PQ is in the ratio of 1 is to 2. And that same ratio will hold true for ST to QR. And that same ratio will hold true for PT to PR. Understood? So that's one point. The other point is that if I square the ratio, yeah, if I were to square the ratio, whenever two triangles are similar, and if I square the ratio of the corresponding sides, what it gives me is the ratio of the areas. So without having any number with me, I mean, all I knew is that PS is equal to SQ. So knowing that, I not only got to know the ratio of the corresponding sides, but by squaring the ratio, I also got to know the area of the corresponding sides. I mean, I got to know the area of the no, I got to know the ratio of the areas. I got to know the ratio of the areas. Therefore, if PST, if area of PST out here in this example was, let's say, 20, then the area of PQR would be how much? It will be 1:4, so it will be 80. And you can check it out by taking an example. Like, let's say if I'm taking a 3, 4, 5 right triangle, yeah, and the ratio is 1:2, so I'll take 6, 8, 10. And I know for a right triangle, the area out here is 3, 4, that 12 by 2, 6, and the area is 48 by 2, 24. And you can clearly see the ratio of the area is 1:4, and the corresponding sides are 1:2. Got it? So 4 by 8 is equal to 3 by 6 is equal to 5 by 10. And if I were to, and because it's 3, 4, 5, and 6, 8, 10, it kind of indirectly tells you that the interior angles are the same. Okay. If I'm not wrong, it should be 37 and 53. 37 and 53, if I'm not wrong. 37, 53 is 90 degrees, and 90 degrees again, the right triangle 90 degrees. So if I'm not wrong, it should be 3753 or 3654, something like that. But yeah, so if you take 3 by 6, which is half, and if you square it, you'll get the ratio of the areas, which I've proved, 6 out here and 24 out here. Understood? So that's it for triangles. There are other properties, but I don't think so. They're going to discuss those properties in triangles. Like, for example, um, that's that Pythagoras theorem one, where they play around with the properties. So yes, there are other properties of triangles where they can play around with it. Yeah. So as far as I understand, I've covered similarity. I've covered the important property where any one side. It's got a name. I forgot what theorem or what property it's called. And I just call it the sum and difference property of triangle. Yeah, but it's got a name. Oh yeah, but one very important property, one last property before I wind up: exterior angle theory. So if this angle is A and this angle is B, then this angle out here, let's call it M. So according to the exterior angle property of a triangle, M will be equal to A plus B. And it's quite simple. If this was C, the interior angle is C, then I know that C plus M is 180 degrees, correct? Yes. And I know that A plus B plus C is also equal to 180 degrees. Yes. Therefore, C plus M is equal to A plus B plus C, right? And C cancel. So what I get is M is equal to A plus B. So that's the exterior angle property. So in my handout, once I complete with the geometry review, there's a question based on this property, and you'll be surprised how they play around with the properties in different questions. Like um, in the previous screens which I was working right now, I showed you how the sum and difference property can be applied to a polygon where the range of the diagonal was asked. Similarly, these properties can be asked in various ways. The important part for you to remember is that not all right triangles are similar. even the for two triangles to be similar, the interior angles have to be the same. Correct? Yeah. And this similarity is not just restricted to triangles. It can be applied to um, rectangles, quadrilaterals also. Again, there are certain rules for that to happen, and then it can be applied to solid geometry as well. So again, there are rules for that also. So if we come across questions, then I'll discuss that. I think in the handout I have covered the similarity part as well. So it will discuss similarity concept and the exterior angle theory concept. So that's it for me. If you have any questions regarding your NET paper, which happened in June, especially related to Part A, you can email me on friendlyspider@gmail.com. Thank you.